Good morning, everybody. In this video, I'm going to explain you about the EMF equation, the induced EMF equation, and the voltage transformation ratio of a transformer. Consider the schematic diagram of the transformer as shown in the figure. The primary winding has N1 number of turns and the secondary winding has N2 number of turns. When an alternating supply voltage V1 is applied across the primary winding, an alternating current I1 starts flowing through the primary circuit. This current I1 establishes a alternating flux phi in the core of the transformer. Then, according to the Faraday's law, EMF will be induced in both of the primary and secondary winding. Let E1 be the self-induced EMF that is induced in the primary winding, and E2 be the mutually induced EMF in the secondary winding. When the load is connected to the secondary of the transformer, the current I2 flows through the load. Okay, now the flux that is established in the core will be varying sinusoidally. So what we can write is phi is equal to phi max sin omega t. This is the standard equation. Okay, so similar to E is equal to Em sin omega t. So phi also will be equal to phi m sin omega t. Okay, here omega is nothing but 2 pi f. Here f is the frequency. E1 is equal to, we know that, okay, this is basic Faraday's law of electromagnetic induction equation. E1 is equal to minus N1 into d phi by dt. Okay, so from equation 1 we can write phi as phi m sin omega t. Okay, substitute that in this equation. So minus N1 into d by dt of phi max sin of omega t. Okay, so we know that phi max is a constant term, so we will bring that outside the differentiating term. So what we will get is minus omega n1 phi max. Okay, what's the differentiation of cos omega t? The differentiation of cos omega t is differentiation of sin omega t is cos omega t. So we will get E1 is equal to, after simplification, we will get E1 is equal to minus omega n1 phi max cos of omega t. Okay, so we will convert the cos omega t into sin omega t. So we know that cos omega t, we can write it as sin of 90 minus omega t, but here we are having minus cos omega t. You can see in this equation minus omega n1 phi max cos omega t. Let us convert minus cos omega t into sin of omega t minus 90. So we can write the equation as E1 is equal to omega n1 phi max sin omega t minus 90. Okay, let this be equation number 2, and the equation number 1 is phi is equal to phi max sin omega t. Okay, so if we compare these two equations, we can conclude that the induced EMF lags the flux by 90 degree. Okay, so we can conclude that the induced EMF E1, so E1 is the induced EMF in the primary winding. Okay, so induced EMF in the primary winding lags the flux by an angle 90 degree. Okay, and we know the standard equation for instantaneous induced EMF, that is E is equal to E max sin omega t. Okay, so let this be equation number 3. Now you just compare the equation number 2 and equation number 3. Okay, so the LHS are same, both the equation number 2 and 3, the LHS are induced EMF E and E, and the RHS you can see we are having sin term. Here sin of omega t minus 90, in the equation 3 we are having sin omega t. So just equate the coefficients of sin omega t. Just equate the coefficient of sin omega t. Okay, so here we are having what? E max. Okay, in the equation number 3 we are having E max. The coefficient of sin omega t is E max. Okay, since we are considering the induced EMF of primary, so I am going to consider it as E E1 max. And what is the coefficient of the equation number 2? That is a coefficient of sin omega t minus 90. It is omega n1 phi max. Okay, so E1 max is equal to omega n1 phi max. Okay, we just got this by comparing the coefficients of sin of omega t in equation number 2 and equation number 3. Okay, and also we know that in the second module, in single phase circuits, we have derived, in AC fundamentals, we have derived RMS value is equal to maximum value by root 2. We have already derived this. The RMS value will be equal to maximum value by root 2. So now let us consider here. So E1 RMS. Okay, so directly we can write it as E1 RMS is equal to E1. Okay, substitute the value of E max that we got here. the equation number 4, substitute the value of E1 max that we have got from the equation number 4 here in this equation. So omega directly I substituted 2 pi f. Omega is equal to 2 pi f. So 2 pi f into n1 into phi max by root 2. Okay. Now simplify this 2 pi by root 2, we will get 4.44. Simplify this 2 pi by root 2, you can use your calculator and simplify, you will get 4.44. So E1 is equal to 4.44 f n1 phi max. So this is the equation for induced EMF in the primary. Similarly, if we solve, we will get E2 is equal to 4.44 f n2 phi max. Okay. So in the equation E1 and E2, everything remains same. Only the number of turns in primary and the secondary varies. Okay. So let the E1 be equation number 6, E2 be equation number 7. Okay. So to find the transformation ratio, divide equation 6 by equation 7. So we will get E1 by E2 is equal to 4.44 f n1 phi max by 4.444 f n2 phi max. So all the terms will get cancelled. We will left with only n1 by n2. So E1 by E2 is equal to n1 by n2. That will be equal to I2 by I1. Okay. So this is the transformation ratio equation.